How we determine the line that fits best out of all lines that we could fit to the data is actually using some calculus, so we won't derive the line, but the idea is that we want to minimize the sum of the squared errors, or the sum of the squared, what we call residuals. And so here's a generic plot with a line fit to some data points, and the idea of a residual is looking at what's the actual y value, which we call the observed value, and then what would you predict as the y value. How we get the predicted y value is we plug x into our equation for a line, and it tells us where we'd expect y to be. In the plot, that's where the line is. So for each data value, we could see like we have this data point here, that is our y, but the line is down here. So if we plug in this x value that goes with the y, what we're seeing is that what we actually get from the line is that y hat would be down here. So that distance between y and y hat is called our residual. So every data value in our data set, every point on this plot, if we look at that vertical distance from the point to the line, those are our residuals. The idea then is to square those so we don't get positives and negatives canceling out, and add them all up, and that term is called SSE. We won't generally calculate SSE by hand, but what goes into finding the equation for the line is we want this to be minimized, or as small as possible. So out of all possible lines we could have, the one that we will calculate is the one that makes this term as small as it possibly could be.